Hello, I will try to explain to you um, in an easy way what is and how do we find the determinant of a matrix. Let's start by saying that somebody is asking you to find the determinant of this matrix. Let's say 3, 2, 1, 4. What I want you to imagine is that this matrix was before another matrix with these characteristics. So somehow this red matrix turned into this new one that they are asking us to solve for. So I'm going to draw a Cartesian plane and we'll try to draw what this red matrix represents. Basically, we could draw something like this 1, 0 could be drawn as an arrow or a vector that goes from the origin, from 0 to 1, because this 1 means 1 in x and this 0 means 0 in y. This is y, this is x, so it's an arrow from here to here. And the other column represents another vector that goes from 0 in x to 1 in y. So basically it's another vector that goes from here to here. And now I am going to draw another Cartesian plane xy, and I am going to draw the new matrix. So 3, 2 means that it's a vector, it's an arrow that goes from 3 in x to y. So basically it's somewhere over here. Here's our vector, and the next column 1, 4 means it's 1 in x and 4 in y. So basically it's somewhere here. So it's an arrow or a vector that has that direction and magnitude. And now I want you to imagine that we can draw some parallel lines that close this figure, and if we know the area of this square, we know it's a 1 by 1 square, so that means it has an area of 1 unit, 1 square unit. And if we do the same with our new matrix, so if we close this figure too, we should have some area in here, and of course this area is larger than 1. For this case, I know that the area of this figure, of this shape, is 10 units, 10 square units, and this is the determinant of this matrix. Basically it says that basically the determinant is as simple as how much larger is this shape compared, this new shape, compared to a 1 by 1 original shape. So, and how do we find this? We find this in a 2 by 2 matrix. It's as simple as 3, 2, 1, 4. We just perform some crossed multiplication and subtraction. For example, we will do something like 3 times 4 minus 1 times 2, and this becomes 3 by 4, it's 12, minus 1 by 2 is 2, so this is equal to 10. So as you can see, the determinant is 10, and this 10 just means that this new figure formed by these two vectors and then closing them with parallel lines, it's 10 times larger than than a 1 by 1 image. So what if the original matrix they are asking us to solve, let's say it's a 3 by 3, let's say a 3 2 1 1 4 3 5 5 6. So the only thing that changes is that now, instead of thinking about this as a square, we have to picture this as a cube. So now, let me see. The Cartesian plane now has also a y-axis. So, for example, let me just clean this a little bit. So basically, now instead of picturing two arrows that become a square, we have to picture three arrows that become a cube. And the new matrix will be some cubic shape that will have again a larger volume now than the original. So the determinant is just telling us how much larger this volume is compared to a 1 by 1 by 1 cube. And if the determinant, if the matrix is larger than 3, let's say 4, 5, 6, or n numbers, then the determinant will, for every case, just represent how much larger it is than identity matrix, which is a 1 by 1 by 1 or more matrix. So I hope this helped a little bit for you to understand how simple this concept is. And on a later video, I will show you how to solve or find the determinant of a 3 by 3 or more or larger matrix. Thank you.